So we have a curve, and we want to write an equation for a line that's tangent at the point 3, 3. So this will finish up our last example from yesterday. We can write it in that space you have in your notes. And what two things do we need to write an equation for a line? Slope and a point on our line. Those two things. What do we have? We have our point on our line is 3, 3. And our slope, how do we find our slope? What's the derivative of x to the third? What is the derivative of y to the third? Very good. Product rule. Derivative of 6x times y plus 6x y prime. Very good. Now, here's a little hint to you, okay? If you would like to, we could solve for y prime. But does it ask to simplify the problem? Does it say give the simplified derivative? It doesn't. And so here's what you can do. We want to find what y prime is, don't we? And we can solve for that by simply plugging in x and y now. Remember when we did that with the product rule and the quotient rule earlier? We never simplified everything because we were just looking for a slope. So if you want to at this time, just plug in 3 for x. 3 squared is times 3 is plus 3 squared, 27y prime, equals 6 times 3, 18, plus 18y prime. So we're trying to solve for y prime, right? So I'll subtract. I get a 9y prime is equal to negative 9. Divide both sides by 9, and I get y prime is my slope. So if it said find y prime in terms of y prime, then you would have to, do some simplifying. But when it just asks for the slope in order to write an equation for a line tangent, then all I have to do is just plug in the values and solve, and that's probably a little bit easier. So now we have y minus 3 is equal to negative 1 times x minus 3. Y minus 3 is equal to negative x plus 3. So y is equal to negative x plus 6. No big deal, right? This is definitely an AP type question. Okay, definitely seen a few like that. Okay, so we flipped our notes I handed to you today. So the last thing we have to do is higher order derivatives. And higher order derivatives is not going to be real challenging for you. You'll get it pretty quickly. And so when people see a lot of these tick marks, they're like, oh no, what are we going to have in front of us? There's some application here that we're going to use later on during the course of the year. And some of the problems we do today, you're not going to be tested on, but I need you to see them so that you're going to be ready when we start to review for the AP exam. So when we get to the AP exam, I want you guys to at least be able to say, oh, I don't necessarily remember this, but I know I've seen it before. And so therefore, we'll be able to hopefully make some speed through it. So the first question, it says examine the functions below and determine which function is f, f prime, f double prime, f triple prime, and f4 prime. You can cross off the f prime 5 because we won't be doing that. What does that mean? Well, if you have a function, say x to the 4th, what is the derivative of x to the 4th? Yeah, so f prime is equal to 4x to the 3rd. What would be f double prime? 12x squared. I just take the derivative of the previous one, right? So f double prime is going to be the derivative of f prime. What's going to be f triple prime? 0.4x. After you write 3 primes, they generally stop writing it, and they are putting the tick marks, and instead they put a number up there to let you know which derivative we're looking for. What would be the 4th derivative? And what would be the 5th derivative? Yeah. Yeah. For example, if you had the infinite derivative of e to the x, we could find that. So let's say f of x was e to the x, the infinite derivative, we could find that. But you're never really going to do that. So this is a tough type of question. You're not going to have this question on your test, but we do need to be able to think through this. This is a type of question we see on the AP exam. It says examine the functions below to determine which is f, f prime, f double prime, f triple prime, and f 4 prime. So we want to be able to look at these graphs and try to figure out which is the original and which is the first derivative, and then go from there. Can you look at this and anybody have an idea of what might be the original function or what might be the first derivative? Here's some hints. I think that where derivatives are equal to 0 are helpful places to look. So what about the blue one? The blue one is the only one that is a derivative equal to 0, correct? So which graph crosses the x-axis? Right here, the derivative is equal to 0 at an x value of 1/2. Which graph crosses the x-axis at 1/2? The red one. Does any other graph cross the x-axis? The blue one does, right? But does any other graph have a derivative equal to 0 at 1? No. So therefore, the blue one has to be the original function. There's enough pieces of data where you'll have to convince yourself, but let's answer Hannah's question here. Hannah, what's the derivative of the blue function here, positive or negative? Negative. Is the red function above the x-axis or below the x-axis at that spot? Below. So the red represents a negative value, being the blue function has a negative derivative at that spot. Let's say you switch it around. All right, let's switch that one around, okay? Look at the red function, okay? Is the derivative positive or negative right here? Positive. But is the blue function above or below the x-axis? It's below, so it could not, the blue function could not be the derivative of the red. Yeah, I'm really looking at these too because the red one crosses the x-axis where this has a derivative equal to 0. But you also need to look at, like I said, where the derivative is positive, where it's negative, where it's increasing, where it's decreasing. So we have f of x is the blue function. Which one is the derivative? The red function. Okay. Now we want to find f double prime. So the derivative of the red function. Somebody complete this sentence. The derivative of the red function is always positive. Why? Yeah, its slope is always positive. So therefore, its derivative always has to be above the x-axis. So the derivative of the red function is either this neon color or this purple color. So we have to try to choose between one of them. So I'm going to go back to Allison's point, and I'm going to look at this slope right here. So if I look at the slope of the red function at 1, what would you say is the slope of that function? 1, right? The slope of that derivative is 1, okay? So which function, the purple one or the neon one, has a height of 1 at 1? Yeah, the green one has a height of 1. The purple one is up more around 2 or 3, isn't it? So the green one is going to be the derivative of the red function, or f double prime. Finish this sentence. The derivative of f double prime is always negative. So therefore, its derivative must always be below the x-axis. So f triple prime is which one? Yep. Finish the sentence. The derivative of the tan function, whatever color that is always, so therefore it's the graph must always be above the x-axis, and the only one we have left is the purple function. So f fourth derivative of x. There you go. So that question won't be on your test, but that is definitely an AP question. So you've seen it once. You have a problem or two to practice on your assignment like that. let's get to some easier problems. It says find the first and second derivative of the following function. So we now want to try to practice taking more than one derivative. What's the first derivative? Minus, plus, f double prime. First derivative, second derivative. And yes, and this is a problem that, we will actually spend a decent amount of time actually taking the first and second derivative of ones that look like that. But that's not going to be an AP question. Okay. B, f prime. What do I have to do to find f prime? Chain rule. Can we try it without making the boxes? What's the derivative of the inside? 2. What's the derivative of the outside? So you multiply, we get 10 times u to the 4th. If you need to make the boxes, go ahead and make the boxes. Derivative of the inside is 2, and then the outside would be 40. So we got 80u to the 3rd. So you should be prepared for your test to be able to take multiple derivatives. Can you do that? Okay. Yes, you can write the box on your test all you want. Okay, let's try one that's just slightly more difficult. And I will write the boxes for you here because people seem to get a little bit more confused on this one. What's the inside function? And what's the outside function? What's the derivative of u to the 1/2? 1 over 2 roots of u, very good. And the derivative of 2x minus 3 is 2. We multiply those together, what's going to happen? Yes, the 2's cancel, right? So I get f prime of x, as Anna said, sorry, square root of 2x minus 3. Like I said, I think last day. I know, but when I see you, I think Savakul. That's what I think. And then I try to reference the first name from there. If you've had a sibling, that's what I think of. I think Rasmussen. But she's the only girl, so it's not a big deal. I didn't. No, I don't. I didn't know that her sister was Taylor until like a month ago. So. No, I don't mix up the boys and the girls. Okay. F double prime. Annika, you have a question you're not asking. All right. So this one right here. There's a couple ways. Tell me 2 different ways you could take that derivative. Okay, I could use the quotient rule, or I could bring it to the top and make it negative. So a 2x minus 3 to the negative 1/2, right? I would rather take that derivative than using the quotient rule. So what's the inside? What's the outside? What is the derivative of u to the negative 1/2? So the 3/2, because negative 1/2 minus 1 is negative 3/2. And what's the derivative of 2x minus 3? So what happens? Yeah, the 2's cancel when you multiply it together. So I have negative 1 over 2x minus 3 to the 3/2 power. That's my second derivative. And if you wanted to find a third, could you do that? It is negative, yep. So since the 3/2 was in the denominator, I leave it. I leave it in the denominator. Okay, D is a little bit more involved. What do we gotta do? Product rule, very good. Some people change theta to x because they don't like thetas. That's fine. Yes, pi is never variable. It's always a number. Always a number. Theta is a variable. It refers to an angle. So f of theta is equal to, or f prime of theta, I would take the derivative using the product rule. Derivative of theta is 1 times cosecant of theta plus theta times, what's the derivative of cosecant? What? Maybe cosecant, cotangent. So I changed the plus to a minus because the derivative was negative. If you look at your study guide, all right. Okay, I gotta find the second derivative. What do I have to do to find the second derivative? I have to do the product rule again, and if you notice here, I'd have to do it twice. What some people decided to do during second hour is they said, well, let's factor out a cosecant, and if we factor out the cosecant, maybe it will make the problem nicer. And I suppose, beauty's in the eye of the beholder. You can decide, whoop, if I factor out cosecant, I get 1 minus theta cotangent of theta. And I do think that this is a little bit nicer if we take the derivative this way. So the second derivative, what's the derivative of cosecant of theta? Negative cosecant of theta. Stupid smart board. Ugh. Turns red. Okay. So I took the derivative of this. We'll pick up when we get back. We'll get some brain food. Hope you had a good lunch. We're in the middle of doing the product rule, and you guys told me that we should factor this out. Take the derivative of cosecant, which was negative cosecant cotangent. What should I write after that? Product rule you told me to write down, so I took the derivative of cosecant, which was negative cosecant cotan. What should I write after that? 1 minus theta cotangent of theta plus cosecant of theta times, I'm doing the product rule, so derivative of this times this left alone plus this left alone times the derivative of 1 minus theta cotangent theta. All right, what's the derivative of 1? 0. So now I need to do the product rule. What's the derivative of negative theta? Negative 1. So negative cotangent of theta plus negative theta times, what's the derivative of cotangent? Negative cosecant squared of theta. I put a negative theta because it's a minus, and then the derivative of, yep, Okay, and so we're just about done. The only thing that you should notice here is that a negative cosecant of theta cotangent theta times 1, and then a cosecant of theta times negative cotangent theta, we're going to be able to combine those terms together. So I'm just going to multiply it all out and then combine my like terms, and then we'll be done. So f double prime of theta is a negative cosecant of theta cotangent of theta. So I'm multiplying that by 1. And then it's going to be a plus. I have a theta cosecant of theta and a cotangent squared of theta. There's another minus cosecant of theta cotangent of theta. Plus cosecant times theta times cosecant squared will be theta cosecant to the third. I only did that so I could combine like terms together. I have a negative cosecant of theta cotangent and a negative cosecant of theta cotangent. So that brings me to f double prime of theta is equal to, I'm going to write this one first. Write this one second. And then how many of those do I have? How many of the blue? Negative 2, yep. Good. So a little bit more challenging than the first two we did on the other side, right? And the last example we're going to do for letter E involves, well, what's different about this one compared to the other two? Yep, and we have to use what kind of differentiation? Instead of explicit, we use implicit differentiation. What's the derivative of 9x squared? 18x. Derivative of y squared? Derivative of 4. I'm going to subtract the 18x over 2y. Y prime is equal to negative 18x divided by 2y. Y prime is negative 9x over y. But it says to find the second derivative. So I need y double prime. Y double prime will be the, what do I have to use to find y double prime? Bullshit rule. Derivative of negative 9x times the bottom minus the top left alone. So plus 9x times the derivative of the bottom. They will not allow you to leave a y prime in the second derivative. How can I get rid of the y prime? That is y prime, isn't it? Now, this is going to look messy, but it simplifies very, very nice. And you will have a problem like this on your test. You have one in your study guide. You have one on your assignment. This is going to simplify very nice. Y double prime is negative 9y plus, um, what's 9x times negative 9x? Negative 81x squared. And then in the denominator, I'll just have y, correct? All over. Oh no, I have a complex fraction. How do I simplify a complex fraction? I have to find common denominators. Common denominator will be y. So we end up now with y double prime is equal to, we have negative 9y squared minus 81x squared all over y, all over y squared over 1, and as Hannah so correctly said, we will multiply by the reciprocal, and that will give me, I didn't mess up, I called you Hannah. Negative 9y squared minus 81 x squared all over y to the third. If I could just factor out a negative 9, if I factor a negative 9 out of the top, I have a y squared plus 9x squared. Does that look familiar at all? It's the beginning. What is y squared plus 9x squared? 4. It'll work like that for these type of problems. This is an ellipse. It'll work like that. So therefore, I get negative 9, or I'm sorry, negative 9 times 4 is negative 36 over y to the third. So that's a classic problem. One that we always, anybody who teaches calculus and higher level derivatives, you always want to make sure you come up with that because it simplifies so nicely, and you're going to want to be ready for that. So you do have a question like that on the test, and I will expect you to simplify it down that far. And you're really smart, so you're going to do a great job of it. Okay. So that was kind of challenging. This is easy. Last example. If we want to talk about higher level derivatives, the reason why is because of application. Higher level derivatives come into play with position functions. If you take the derivative of the position function, you get the velocity function. And if you take the second derivative of the position function, that is the derivative of the velocity function, which happens to be the acceleration function. So acceleration is the second derivative. A jerk, trying to think of, it came up during second hour. Some people thought I was being mean when I was asking, give me an example of a jerk, and they wanted to name names. If you think of, I guess maybe, I wonder if torque could be considered, as a measure of things within cars and vehicles. Anyway, that's going to be the third derivative, and we won't even look at it. Okay, it's not a big deal. So it's not part of the AP exam, and I've never seen it come up before. Well, the book has it, and so I wrote it down, but I don't see any time where we really come into it, so I'm not going to mess around with it. The equation of motion is given for a particle where s is meters and t is in seconds. Find a, the velocity function. If that's my position function, what is the velocity function? V of t is? Good. B says the acceleration at time 1. First, I need to find the acceleration function. A of t is equal to? So we've taken a first and a second derivative. One tells us velocity, the other one tells us acceleration. So the acceleration at time 1 is equal to? So can you think of a situation where you're in a car and you have positive velocity, but you have negative acceleration? You're slowing down, you're applying the brake, right? When would you have positive velocity and positive acceleration? Foot on the gas, you're speeding up. When would you have negative velocity but positive acceleration? Yeah, you're backing up, and you're accelerating, you're backing up. Foot is on the gas. Yeah. So you can think of these situations as they present themselves, and we'll get into more of them later. But finally, C, the acceleration when, sorry, not with, when the velocity is 0. How would I figure out the acceleration when the velocity is 0? Very good. Velocity function equal to 0. So 0 equals 3t squared minus 12t plus 12. We said the velocity function equals 0. I factor out a 3. So at what time does that happen? At time equals 2 seconds. Did I answer the question? No. The question is what is the acceleration when the velocity is 0? So I need to calculate a of 2. Plug in 2 and you get. Now, I apologize, but I made a small mistake here. The label for acceleration is not negative 6 meters per second. That would be velocity. It's meters per second squared. That is the label for acceleration. So again, this would be 0 meters per second squared. So, um, so we found out that the velocity is 0 at 2 seconds. I then take 2 and I plug it in for a. 6 times 2 is 12 minus 12 is 0. And there we have it. So, okay, some of these problems go by pretty quickly. Okay, if you notice, the last problem we did was pretty quick. Some problems at the beginning were pretty quick. I have reduced the assignment from last year. I know you guys are feeling the weight of it. I appreciate your hard work. As I said, we really got to keep to a schedule. I checked when I gave this test last year, and it's I gave it 10 days ago last year. So part of that's because we started later this year. You know, it was the latest start that you can have for a school year this year, but last year was one of the earliest. But we got some spots we're going to be able to cut down on time coming up here, but I yes, school is goes a little bit later this year.